Hi and welcome to this week's video. In this episode we're going to continue our Breaking Bad escape room series and we're going to take a look at creating a puzzle. Let's dive right in. It's that time of month where I'd love to say my thank yous to all of the people over at Patreon who are helping to support me and making these videos possible. And they are Wanglan Goyen, John K, Hassan Karuni, Cat, Travis Duff, Pablo Riviero, Gmiv, Stanton Nash, iEducator, Briflaben, Marvin Church, Peter, Eric Kane, Wonfyong Choi, Javon Poulter, VR Animated, Eli L, Hexodus and Harold Gunderson. Thank you very much guys, I can't tell you enough how much it means. It's awesome to have your support. I'm hoping I'm doing you all proud and you're getting a lot of useful stuff over there. I aim to keep it coming and making these videos better and more useful for you guys. So thank you very much. Now on with the video. So before we get started, I've got my little test scene here. Now this is all that's in here at the moment is our XR rig, and you can get this all from the first tutorial in the series that shows you how to create the XR rig. And we've got our hands set up, which was our second video. You don't need any of that to actually follow along with this tutorial. This could all be standalone if you like. And what we're going to look at is how we can use the socket interactors to create a puzzle. Now, most of the time you'll notice in games you'll have these quests where the actual objective of the quest is fairly simple. Once you strip away all the narrative and the storyline, is that you go somewhere to find a thing, bring it back, and it does something else. Well, that's kind of what we're going to be doing here. We're going to have this puzzle. This is our puzzle, our unit. And you need to put in 3 things in a certain order that will then give you a prize at the end of it, which will then go on towards another quest. Now, the objective of our game is an escape room. So what the idea of this is that it opens up at the end once you've found how to solve the puzzle, and there'll be part of the clue that gets you out of the room. So let's take a look at how this is working, and then you can get a good idea of what we're going to be looking at in this tutorial. So here we are inside my VR environment. I've just got my right hand for a minute. So nothing funky going on, just normal hand as my previous tutorials, really easy to set up. These objects here, they're literally just grab interactors, that's it. There is honestly nothing fancy going on in this scene, and it's not complicated at all, but it allows you to get a lot of functionality and create and build your puzzles with a lot of flexibility. So the idea of this puzzle is you might have some UI telling you what you've got to do, or you might just leave it and let the player figure it out on their own. So this is a puzzle that you might see in games such as the Room VR, where you might have to go around the environment, find certain things, collect them, and then sort it out in a puzzle, which again gives you a reward or a clue. So we've got these canvases, and we might be thinking, well, what do we do with these? And you'd look at the end and you see it's got like a little hole in the end, and you see this machine and go, ah, okay, well, what about, does it go in there? And then you might slot it in. So these are just socket interactors that this is clicking into. And as you can see, it doesn't do anything, but we've got 2 more holes. So the player might think, okay, well, obviously I need to go and find 2 more of those around the environment somewhere. Ta-da! So they might bring them back, pop them in the machine, like so. And nothing happens. That's because they need to be put in a certain order. Now you could have like little lights on here that indicate that the wrong tube is in the wrong section if you wanted. That's something you could easily set up. But it just goes to show you how you can build simple little puzzles using the XR Interaction Toolkit. So if you know your colors, it's RGB, so it'd be red, green, blue, and then the top opens up to reveal our secret inside, which we haven't done yet. And then that secret would be maybe like part of the code that gets you out of the room. So let's have a look in Unity at see how this is all put together. So as I said before, this is nice and simple. You got our XR rig, nothing fancy going on there apart from our hands. And we have some cubes, and these are just cubes with a collider on, so our little color capsules can sit on top. And these color capsules, all they've got on it is the XR grab interactable, and then that automatically adds on the rigid body and a box collider as well. And you'll notice that on these capsules, I've got my art separate from my script. So the parent object is just the scripts and the collider, and then I can always swap out the art quickly if I needed to. So that's an XR grab interactable. And then we've got our puzzle unit, which has an animator on it, which is just a little top opening. And then literally all it is are these socket interactors. And these are kind of where the bulk of the logic is coming from. And this socket interactor has a puzzle element script on it, which is looking for a linked puzzle controller, which is on our root of our puzzle, which contains all the puzzle pieces. And this controller is just monitoring the steps that we've taken as we've been going through the puzzle. But all the logic is coming from these socket interactors. So let's start afresh and go through it together, and we can see how we can easily create a puzzle. So let's dive straight in. Let's have a look at this scene. This is just a very simple scene I've got set up with my XR stuff, just my XR rig. And you don't need your hands even to be able to do this. You can just use the default rig. We got a light, we got some static art, which is just the ground, these two cubes, and that's it. And then we have a 3D model of our puzzle container. And this could literally be anything you want. You don't even need it. What we're going to use this for is to use these holes in the model as snap zones. And that'll make more sense later. And hopefully you'll be able to see as this tutorial goes through that you don't actually need any of this art. You could actually just do it using snap zones and just the standard primitives, just so you learn what's going on. This has an animator on it called puzzle. I'm going to click on. And you can see in the animator for that object that its default state is idle, but it contains a trigger, a transition called activate, so that when we tell that animator, the animation will play and the two panels on top will open up to reveal what's inside. So that animation just opens up there. But that's not going to play until we tell it to. So to tell it to open, our puzzle means we're going to need to put in 3 objects into our puzzle container. So what I'm going to do, just to keep everything nice and neat, is to create an empty object, and I'm just going to call this puzzle. So everything associated with our puzzle is going to be stored in here. It's going to make sure it's at 0, 0, 0, and the scale's 1, 1, 1. And I'm going to drop in my 3D artwork for my puzzle box, just there. Now we have that, we're going to need some pieces that go in here, just some artwork, some grabbable objects that we can pick up. And I've already made those, but again, you could literally use any model. I've got this puzzle color module here, which sounds way more important than it is. It's literally just a 3D model, a cylinder that we can assign a different color to. So we can go ahead and drop one of those in the scene and put it on the table just there. And there's 2 elements to this model. You can see I've got the middle and the end. So I'm just going to put a material in the middle. I've got some materials set up. Let's make this one the blue one, like so. On its own, this isn't doing anything. You won't be able to grab this. So I'm going to make another empty game object. I'm going to call this blue module. I'm going to drag it and put it inside our puzzle color module. So it sits inside here. I'm going to center it as 0, 0, 0. And I'm going to lift it up to the center. So now this gizmo is right in the middle of our puzzle piece. I'm now going to drag it out. It's a little bit of jigging it around. So that blue module is its own little empty game object, but now it's in the right position. So all we have to do is drag our puzzle column module art into our blue module. So now when we move the blue module game object around, you can see it moves the module as well. And then on this blue module, we're going to add in a box collider. And it's going to be massive. That's okay. We can click on Edit Collider. And we'll go into the side view here. I'll center it on that object by pressing F. And then we just want to resize that collider so it fits nicely around our artwork. There we go. Let's just check the other side. You can hold down Alt as you click and drag, and it's going to do both sides together. There we go. That's that all set up. So now on this parent object, we've got a box collider. And we want to be able to pick this up. So we're going to add in our XR grab interactable. And that is going to add on the XR grab interactable script and the rigid body. So what we've done here is we've been quite clever in that we've separated our art from our interactive stuff. So that if any time we decide we want to change this artwork or change the look of the module, all we need to do is toggle the game object off, drop in our new component, and you can swap it out really easily without having to worry about any of the interactions or the code inside of stuff we've got on the parent object. And then we need to duplicate that a couple of times because we've got 3 bits that we need for our puzzle. So we can go 1, 2, and we've duplicated those. And then we want to rename them. We'll call this one red module, and we'll call the last one green module. And then we'll put the right materials on. So on our red, we'll put the red, and on green, we'll put the green. Mess that up. That should be green. Put the green. What's this one? Red, green, blue. Awesome. So now we've got 3 items in our scene that we can pick up. They're not going to be doing anything special other than the fact they've got the XR grab interactable on it, and that's it. So next, let's have a look at setting up our socket interactors. Okay, so let's create a socket interactor, and this is really easy, you'll be glad to know. We can right click in our hierarchy, go down to XR, and then socket interactor. And that's going to place this in your scene. It's got like a spherical gizmo on there. I'm going to rotate that 90 degrees so the forward direction is like so. I think I've got mine set to local. How do you check it in this? So yeah, I've got it on local space for a minute so I can see what I'm doing. And then I just want to move this into position so it's in the center of one of these holes, like so. It might take a little bit of going backwards and forwards to get this right. And then I'm going to reduce the size of the sphere collider so they don't overlap, and hopefully we won't fire 2 at the same time too much. And we can do that by just adjusting the radius of the sphere collider. So we can go say 7.08. Try that. And at the moment, if we were to snap anything into this socket interactor, it would come in and it will snap in a funny position. So we need to tell it what orientation to go in. So select the socket interactor, right click, and go create empty, and we'll call this orientation. And then for the minute, we'll adjust this in play mode in a second, but let's rotate it 45 degrees like that, so it's pointing up. And let's try and snap something to there to see where we've got to, and then we can edit it in play mode. So let's pop on our VR headsets, press play, go around the scene, we'll grab any of our snap objects, and you can see here that it's not quite round the right way. It's pointing straight up. So what we'll do, I think I know why. This isn't going to help us. If we come out of play mode a sec, go to socket interactor. And I'm going to drag our orientation into the attach transform. What a dummy. And then hit play again. Otherwise we're going to be adjusting it and nothing's going to be happening. Grab the blue. Now you can see that it's snapping. It's going in a funny orientation. So whilst we're in play mode, swap back to our scene view a second. Let's rotate the orientation around until it's the right direction. Probably had it right the first time. Let's try that. Let's bring it forward a bit or up a bit. And then we want to click on the 3 dots and we'll go copy, component, come out of play mode, highlight the orientation again, select the 3 dots and go paste component values. And it's going to switch into the one we just manipulated it to in play mode. So then when we go hit play, jump into our scene, grab something, and you can see the highlights coming in the right place. We let go and it drops straight in there. So that's cool. And now actually it's really easy to set up the others, because all we need to do is go Control D and duplicate it once, Control D, duplicate it twice, move one to the middle, and then we'll move one to the right. So now we've got our 3 socket interactors. The way I thought this puzzle could work is that you have to put them in order. Have to be red, green, and blue. So let's name our socket interactors so they're correct. So socket interactor red, blue, and green. So now we've got our socket interactors set up. We can put any one of our components in these sockets. In fact, anything that had a XR grab interactor would go into these XR socket interactors, and that's okay. It depends on what kind of interaction you want to achieve with your puzzle, but at the moment we could put any one of these 3 in any one of these 3 socket interactors and be able to interact with them and swap them out and change their places as we want to. Another thing we'll quickly do before we go ahead and start building the scripts is on the socket interactors, we have the hover mesh material. Because it came up blue when I hovered over, that might seem to the player that that's the one that the blue piece should go into. So we're going to change it for a color that we haven't used as part of the puzzle pieces. So we'll create an orange piece. Let's go material, and we'll call it orange. Change it to orange. Might need some emission. Let's do that. Nice. And then on our socket interactors, highlight all three, and we'll drop in the hover mesh material. So now we have all the functionality of our puzzle built. We've got our puzzle container, we've got our modules, which are just XR grab interactors, and we've got our socket interactors where you can put the modules in. At the moment, there's no logic that's going on in the background to work out whether we've completed the puzzle or not. There's no puzzle logic at all. So we're going to create that now. And our first port of call is to select all our puzzle pieces, and that's all the modules and the socket interactors, and we're going to drop it into our puzzle game object. So inside this puzzle, if we turn it off, you can see all the puzzle bits go away. Just keeps it nice and neat. So we're going to be writing two scripts, and they're both very small scripts actually. One is like the puzzle controller, that is the master of the puzzle, and then there'll be another script which will sit on our socket interactors, which is a puzzle component. And the two will talk to each other to establish whether we've completed the puzzle or not. So let's go ahead, let's make those scripts. If we go to your scripts folder, I'm going to create a new folder here. I'm going to call this puzzle YouTube scripts. And inside here, I'm going to create a new C# script. I'm going to call this puzzle. You can call it puzzle controller, puzzle manager, whatever you want. I'm going to call this puzzle manager. That's going to compile. And we're going to go ahead and drag and drop that on our puzzle game object, which is the root of everything. See, it's got the puzzle manager script just there. And then we'll go ahead and open this up in Visual Studio. Okay, so the first thing is it's tiny, so let's make it bigger. And as I said, the idea of this puzzle manager script is to establish whether we've completed the tasks that we need to do in order to get our reward for the puzzle. So this puzzle manager is going to trigger our animation event on our container to slide open those doors and reveal the solution to the puzzle, or the prize if you like. So let's get stuck in. Let's remove start and update. We don't even need those. We will be using events though, so we'll go ahead and put that namespace in, which is using Unity engine.events, and we won't need systems collection or system collections generic, so we can go ahead and remove those. So we will need a private variable here, which is going to be an integer. It's just a number which is going to represent the amount of tasks that the user needs to complete to be successful. So we'll go ahead and put this so we can see it in the inspector, and it's a private int, and we'll call this number of tasks to complete. Bit of a long variable name, but it keeps it clear what we're doing in the tutorial. Then we need another private variable, another int, and this is going to be keeping track of the tasks that we've so far completed. This is the max tasks that we need to complete. Now we need to keep track of how many we've currently done. So we'll call this currently completed tasks. And that, when we start, is going to be equal to 0. And now we need to create our event for when we complete all of our tasks, when we complete the puzzle. And I'm going to give this a title in the inspector, so I'm just going to say header completion events, and we're going to make this public Unity event, and it's going to be called on puzzle completion. So we're going to need a couple of methods here that's going to handle our logic for checking whether we've completed the puzzle or not. So let's say we put in our socket interactor, when we create our puzzle component, it's going to be looking for our puzzle manager to say that we've completed a task, and to check to see if we have completed the complete puzzle. So let's create a method which we can use where we say we've completed a task and check for completion. We'll call it public void completed puzzle task. So when we put something in the right place, we want to increment our currently completed tasks by 1. So we just go currently completed task plus plus. We're going to add 1 to it, and then we're going to check for puzzle completion. Have we done all of our tasks? And we'll use a method for that, which we'll write in a second. Now we can just call that method by going check for puzzle completion. As I say, it doesn't exist yet, so we can left click on the squiggly line, control full stop, and then we're going to hit enter on generate method. That's going to put it just below. So in this one, we just need a simple logic statement. We're going to use if currently completed tasks is greater than or equal to number of tasks to complete. Then we can call up our event on puzzle completion dot invoke. That'll fire the event. So all we're saying here is that if we've currently completed 3 tasks, it's going to compare it to the number of tasks, which is 3. It's going to go, okay, I'm equal to the number of tasks, so you've completed the puzzle. If the currently completed tasks is only 2, it's just going to bypass this if statement and just carry on. So that's it so far, nice and easy. But what happens if the user removes a piece that's in the correct position, because it is a puzzle after all, and they don't know what the answers are? They may have put it in the right place. It's going to come through here and it's going to add 1 on to our puzzle completion, but then they remove it. And currently there's no way to know that at the moment. So what we'll do is we'll create a method called public void puzzle piece removed. And this is only if it's the correct piece in the first place, which we'll do that logic in another script. And all we want to do, because it was right, we are now just going to take that off of our currently completed tasks number. So currently completed tasks minus minus. That's just going to take 1 off if we've removed one that was in the right place. This will make more sense when we go through it and it's actually running. Don't need that using system, it's snuck back in there. So this is actually all that's required for the puzzle manager, because we can hook up the ending, the animation of our unit into this Unity event here. So let's go ahead, let's minimize this. Now you can see you've got the puzzle manager, number of tasks to complete. Well, we've got 3 bits to our puzzle, so we'll put in 3. Once the puzzle's complete, we want to grab our puzzle container, look at the animator, and we want to set a trigger. And that trigger on the animator is called activate. So we'll go ahead and type activate in there. I always like to cut and paste because I always spell it wrong. So I can paste it in there. So as soon as the puzzle's complete, I'm going to set the trigger on our animator to open the slidey doors. So that's our puzzle manager written. But we need one more script, and that's to control the logic on our socket interactors to know whether we've put the right piece in or not, and then tell the puzzle manager all about it. Let's have a look at writing that script now. So we're going to go ahead and create a new script, and we'll call this puzzle piece. And we'll go ahead when that's compiled, and we'll drag and drop that onto our socket interactors. Each get 1. Boom. Let's go ahead, double click that, and open up in Visual Studio. Now again, we don't need the 2 system using statements, so we'll go ahead and take those out, but we will need the XR interaction toolkit. So we'll go using Unity engine .xr .interaction .toolkit, and we don't need our start or our update functions, which is cool. We'll need a couple of variables. We will need to know all about the puzzle controller, so we're going to go ahead and say serialize field private. We want the puzzle manager, which I've got just there. That's the script we've just written, which is this here, and that's going to be called linked puzzle manager, and then the semicolon. Now we also want another serialized field private, but this one's going to be a transform type, and this is going to be the correct puzzle piece. We're going to store that as a transform, and then we want a link to the socket interactor, so we can say, don't need to see this in the inspector, so we can say private XR socket interactor, and that is, we'll just call that socket. We'll know what that is. So our first port of call is to get a link to our socket interactor, which is this here. We want to assign this variable, and we'll do that in awake. So we say void awake, and we can say socket equals get component xr socket interactor, and that's it. That just assigns this socket interactor as a variable. And to make this nice and neat, we can left click on socket, control, full stop, and use expression body for method. We're not going to use the awake for anything else. We are going to use on enable, so we can start typing on enable and it comes to the top of the list, hit enter. And here's where we're going to hook into our socket interactors events. Specifically, we want to be listening to the select entered event, so when something's snapped into place, and the select exited when something's removed. And we can get a link to those in our script. And to do that, we can say socket dot select entered, and we're going to add a listener to that event. Once that event is fired off, we can assign a method to it, and I'm going to say object snapped, and that doesn't exist yet, so we can left click, control, full stop, and generate method like so. And we're also going to want to listen to the select exited event, so socket dot select exited dot add listener object removed. Again, it doesn't exist yet, so control, full stop, and we've got the two methods there. I'm just going to cut the object removed and put it below the object snapped so it all flows in a nice order. I'm going to get rid of the two throw lines. Because we've added some listeners on enable, we can remove those listeners once they're disabled. So we can go on disable, and we're going to cut these two lines, or copy rather, and paste them in the disable method, and we'll change the add to remove like so. Let's go ahead and write our object snapped. We can get hold of that through this select event args variable that's being passed to us. So I can say var snapped object name is going to be equal to arg0 dot interactable object. This is the interactable object that's been snapped in the socket. So now we have to establish whether that object is the correct one or not. So we can use a bit of logic to say if the snapped object name, if that transform dot name is equal to this transform, which is the one we've put up here, which is the correct puzzle piece, dot name. So if those two transform names are the same, then it's the correct piece that's in this socket. So we can then tell our puzzle manager, which is stored in our linked puzzle manager, we can then say that we've completed a puzzle task. So if transform has been snapped in, so let's say I pick up the red container, this transform name is red module. If that matches the correct puzzle piece, which we'll link up in a second, if those two names are the same, then we've effectively put the right piece in the right hole. So many jokes. And we've completed a puzzle task. But what happens if I remove that puzzle piece, because I'm not sure whether it's right or not? Well, we need to tell the puzzle manager to take one off of our completed tasks. So we can pretty much use exactly the same logic. We can in fact copy all of that, put it in there. To make it clear what's going on for you, I can change that to removed and change that one. And then all we need to do is tell the puzzle manager that we have removed a piece, which is catered for here, puzzle piece removed in our puzzle manager. We can say puzzle piece removed, and that'll help us sort that out there. So that is actually all of the logic done. Let's get rid of that system that keeps sneaking in for some reason. So nice and straightforward, leveraging the power of the events to end our puzzle, and just a little bit of logic to see what's been entered into our socket and if anything's been removed from our socket, and then just testing the names. Let's hop back into Unity and wire this all up. So we'll close that. So let's go to our socket interactor where we've got our puzzle piece script. So it wants a linked puzzle manager. Now we could have found that through code, but I'm just going to drag and drop it in. It's on the root of our puzzle. There you go, puzzle manager. And then we want to know about what is the correct puzzle piece for this socket. Well, that's the red one. So we'll get the red module and we'll drag it into the correct puzzle piece. Let's do the same for the blue. Let's drag in the blue module and the puzzle manager. Is that one done? And then same for the green. It wants to know about the puzzle manager. And it wants to know about what piece is correct, which is the green puzzle piece. So just to make it clear to you what is actually going on, and so that you can see this is working correctly, in my code for the puzzle manager, I'm just going to make the currently completed tasks serialized fields so we can see it in the inspector, and then as I'm removing them, you'll be able to see it change, so you know that it's all working. So now I'm puzzle manager, I've got currently completed tasks. Let's jump into VR and have a look and see, make sure this is all working as we expect it to. Okay, so I've got my blue piece. Now, but because I know how the puzzle works, it goes RGB. I'm going to put the blue one in here. See, it highlights. They all highlight because it can go anywhere. I can release. And I got these round the wrong way. What a moron. Hang on, what's going on? I've put blue in the wrong spot. Green and blue are mixed up. I wonder how many of you were shouting at the screen in furiousness. And where am I as well? There we go. So the blue is, it's not RBG. In my world it is. But we can move that over to the right and then move the green to the middle. Let's try that again. Oh dear. I think I need to do some tutorials. Right, so we've got our blue piece. R, G, B. We've slotted in there. Let's go back to our puzzle. And now you can see the currently completed tasks has jumped to 1. But what about if I remove this piece? Should be now 0. There we go. Currently completed task 0. I can put this in there. This socket interactor is looking for the green piece, so it's still 0. Then I can put it back in there. I can put my green there. And I can put my red there. Completed my puzzle, and you see the door opened up, and I'll be able to reach in, and we can. This will be the clue that gets us one step closer to opening the door in the lab. But I can remove that. And the currently completed tasks will change, but the puzzle still is like effectively completed. So whether you're not, you want to close the hatch or do whatever, that's up to you. But that's kind of how you would wire it up. So hopefully that's given you a good idea of how you can easily construct puzzles in VR, and just how simple it is. I mean, you saw there's literally like 2 scripts, really tiny, not a lot going on at all. I mean, you can get as complicated with it as you like. I've tried to keep it nice and simple. All it's doing is comparing the name of the piece that's been put into the socket to see if it's the right one or not. If it isn't, nothing happens. If it is, you get a point and 1 step closer to completing the puzzle. And this system will still work if some douchebag comes along and adds something to the name or changes the name. That'll still link itself up in the puzzle piece script. So I hope you like this video. In the next one, we'll take a look at maybe another puzzle type that we can put in the lab to allow us to get the code to get out of the door. Even if you're not looking to make an escape room game, at least it gives you an idea of how you can construct puzzles using the XR Interaction Toolkit.